In example 3, we are using the product rule to differentiate. So we have product of x to the 7th power times natural log of 3x. So we will use the product rule and do first times the derivative of the second plus second times the derivative of the first. Okay, so here my first piece is x to the 7th power. Then f prime is 7x to the 6th power. G is natural log of 3x, and this is a new topic, right? But remember, we did this one already. We found the derivative of natural log of 3. Let me scroll up and see, we found that already. And derivative of natural log of 3x is simply 1 over x. So let me just copy that down instead of doing it all over again. 1 over x. So I'm ready to do the product rule. So what is y prime? Y prime is first times 7x times the derivative of the second, which is this 1 over x, and that's going to be very nice. We will be able to simplify this. Plus, what's next? Second times, which is natural log of 3x, natural log of 3x, getting multiplied by the derivative of the first, which is 7x to the 6th power. So we're all done. Now we're going to simplify this a little bit further. Now we have 7x to the 7th power getting divided by x to the 1st power. Well, I can write this as x to the 6th power, right? X to the 6th power plus, now I'm just going to write this in front, okay? I'll have 7, not with the highlighter, 7x to the 6th power times natural log of 3x. So all I did was I just switched the order. And now I notice that they both have x to the 6th power. So I'll factor that out and have it in front. If I write down x to the 6th power in the front, inside the parenthesis, I will have 1 first. And if you're wondering where'd you get 1 from, I really did x to the 6th power divided by x to the 6th power, and that is 1. Anything divided by itself is 1. And then plus, now what's left? If you pull that out to the front, the only thing left is the stuff that is not highlighted in gray. So I will have 7 natural log of 3x in the parenthesis, and that's it for this example. Okay, we found the first derivative, and that's all they wanted. That is good. All right, let's go on and try another one. Now this one is different. Now look, if you have natural log of x divided by x to the 5th power, this is not the same thing as natural log of x divided by x to the 5th power. Okay, they are not the same thing. The numerator function is natural log of x. The denominator function is x to the 5th power. So I cannot say this is the same thing as natural log of x minus natural log of x to the 5th, because x to the 5th power is not under or not in the natural log. So unfortunately, I'm sorry, we're going to have to review the quotient rule. Or, hey, hold on a second. I have an idea. How about we rewrite this? Instead of y equals natural log of x getting divided by x to the 5th power, guess what I'm going to do? I'm going to say this is getting multiplied by x to the negative 5th power. Now I can avoid the quotient rule. I can just go with the product rule. Don't you think so? This is pretty nice. So I have, that is my first piece of the multiplication, and that's my second piece of the multiplication. So let me go ahead and label all my pieces. F is natural log of x. Then what is the derivative of that? Well, that is 1 over x by theorem 7. Next, g is x to the negative 5th power. That means g prime is negative 5x to the negative 6th power. So I didn't want to use the quotient rule, so I just rewrote it so that this became a product instead of a quotient. So let's go ahead and do the product rule. which is first times the derivative of the second plus second times the derivative of the first. So what is our final answer, y prime? And we're going to have to simplify this a little bit too. But let's start with first. First is natural log of x. So I'll say natural log of x times, what are we multiplying that by? G prime, which is this right here, okay? And that is negative 5x to the negative 6 power, plus sign after that, and moving on to g is x to the negative 5th power, x to the negative 5th power, and that is getting multiplied by f prime, which is 1 over x. And as you can see, we have some simplifying to do, don't you think so? All right, let us simplify this then. Y prime is anything that has a negative exponent, guys, I'm going to send it to the bottom, okay? See, this right here has negative exponent. So x to the negative 6 power is the only thing that's going to the bottom of the fraction. So in the bottom of the fraction here is my happy x to the positive 6 power. When we moved it, it became positive. All right, on the numerator, I was going to write natural log of x and a negative 5, but let me just write the negative 5 in the front and then natural log of x so that it just looks nicer, okay? All right, what's next? Plus, and I'm looking at this. What is this? That is 1 over x to the 5th power, isn't it? So what that means is if I multiply 1 over x to the 5th power by 1 over x to the 1st power, we will get 1 over x to the 6th power. This is awesome. Why am I saying this is awesome? Because look at these two fractions. We can combine them. They have common denominator already. So I will have x to the 6th power in the denominator, and we'll have negative 5 natural log of x plus 1. Or, you know why I draw that parenthesis after x? Because I wanted to make sure that I close that argument. Or you can switch the order and have 1 minus 5 natural log of x over x to the 6th power. I like the second one better because I don't have to put parentheses around my argument of x. I can just write it as ln x, okay? But that's it. That's how you will do that problem. I will stop this video here and we'll come back with example 4 soon.